Normally, an array is a collection of similar type of elements which has a contiguous memory location. Java array is an object which contains elements of a similar data type. Additionally, the elements of an array are stored in contiguous memory location. It is a data structure where we store similar elements. We can store only a fixed set of elements in a Java array. The syntax to declare an array in Java is you have a data type, then square bracket, then array name, semicolon. So this is an instantiation of an array in Java, or we say creating an array object in Java. So we use the new keyword, variable equal new, then we have the data type, then in the square bracket we have the size of the array. Here we declare an array as 20 elements. If later we refer like 60 elements, that will have an error because the subscript is too large for an array. We call it out of bound. Array in Java is index-based. The first element of the array is stored at 0th index. Second element is stored at first index, and so on. We can store primitive values, for example, integer, double, or objects in an array in Java. Like C or C++, we can also create single-dimensional or multi-dimensional arrays in Java. Moreover, Java provides the feature of anonymous arrays, which is not available in C++. We can declare, instantiate, and initialize the Java array together. So in this example, we have an integer which tells that integer type, then square bracket tells us it's array. The array name is a 10 mode. Then we assign a list 10, 20, 30, 40, 50, 60, and those initializing data are enclosed in the curly braces and with the semicolon. We can store only the fixed size of elements in the array. The array doesn't grow its size at runtime. In an application that includes an array, it is convenient to declare a named constant equal to the size of the array and use it as a limiting value in every loop that processes the array. We have a statement like a final integer number of scores equal 5. Final is the constant keyword. We can use a subscript to access each array element. In this example, we have a for loop, for sub equals 0, sub less than 5, plus sub. We have a score array, sub, then plus equal 3. So we loop through from index 0 to until index 4, and then we add 3 to every array element. The array object has an property called the length. So instead we use 5 here, we can just use a score array dot length. It returns the length of the array. Pay attention, we have the length here. It's not a method, it's a property. So we don't have a round parenthesis after length. So we call score array dot length. You can also use the constant you declared like in the previous slide. If you didn't declare the constant, we can always use the dot length to get the length property. We can also access the Java array using for each loop. The Java for each loop accesses the array elements one by one. It holds an array element in a variable, then executes the body of the loop. In this example, VAL is defined to be the same data type as the array after the colon. Within the loop, the VAL takes on, in turn, each value in the array. You can read this example as, for each VAL in score array, display VAL. We can declare arrays that hold elements of object. For example, assume we create an employee class. We can create an array of employee objects. An array named EMPS that holds 7 employee objects can be defined as employee square bracket EMPS equal new employee 7. This statement allocated enough computer memory for the array, but it didn't actually construct or instantiate each array element as employee object. In this for loop, it constructs each employee object for every array element. Because the employee class has two arguments, the first one is the employee number, the second one is the employee salary. So for the constructor, we pass two parameters, and we use the new keyword, and we assign the object to the array element. We can use the enhanced for loop to circle through an array of objects. For example, to display data for 7 employees stored in EMPS array, we can write the following. For employee worker EMPS, we have a printout line, then worker, then dot get employee num, then worker dot get salary. So in this loop, the worker is a local variable that represents each element of EMPS in turn. Using the enhanced for loop eliminates the need to use a limiting value for the loop and eliminates the need for a subscript following each element. We don't need a counter and we don't need the length of the array. We can create an array of string objects. For example, we can store 3 company department names as the following. So string, square bracket, it tells us it's a string array. Then the variable name, department names, and each element is a string object, and we have 3 elements. So if we want to know the length of the array, it's a property. So we say department names dot length. For the string object, the length is a method. So whenever we access the index element, for example, we access the first element of the array, we say department names, then inside the square bracket, we put the index like 0. Then we have a dot length parenthesis, because that's a method for each string object. For the whole array, the length is a property, so we don't specify the round parenthesis. We can search in an array, which is the process to compare one variable to a list of values in an array. We can use a for statement to loop through the array. So here we have a for statement to loop through valid values array. And we are searching the value item ordered. And the is valid item is a boolean. If the value is matched, then it will return true. If all the elements in the array are checked, but the matching is not found, then we return false. Parallel array, also known as a structure and array. Multiple arrays of the same size such that ith element of each array is closely related and all ith elements together represent an object or entity. In this example, valid values array and the prices array, they are parallel arrays. So in the for loop, when item is found, the item price value can be pulled from the price array. In other words, if the item number is found in the valid values array, you can find the correct price in the same position in the prices array. The individual array elements are passed by value. That is, a copy of the value is made and used within the receiving method. When any primitive type like a boolean, character, short, integer, double is passed to a method, the value is passed. Arrays, like all non-primitive objects, are reference types. So this means that the object actually holds a memory address where the values are stored. Because an array name is a reference, You cannot assign another array to it using like the equal sign operator. Nor can you compare two arrays using equal operator. Additionally, when you pass an array, that is, you pass its name to a method, the receiving method gets a copy of the array's actual memory address. This means that the receiving method has access to and ability to change the original values in the array elements in the calling methods. In this figure, we have an integer array, some nums, and have 4 integers. Then we pass this array to method getArray, and we just pass the name of the array as a parameter. In the method getArray, then we have an integer square bracket that indicates the parameter is an integer array. And inside this method, we actually change array element's value. In the main function, if we go back to the main function, if we print out this array, the new value will be displayed. Like all Java objects, arrays are passed by value, but the value is the reference to the array. So when you assign something to a cell of the array in the called method, you'll be assigning to the same array object that the caller sees. This is not pass by reference. Real pass by reference involves passing the address of a variable. With real pass by reference, the called method can assign to its local variable, and this causes the variable in the caller to be updated. But not in Java. In Java, the called method can update the contents of the array, and it can update its copy of the array reference, but it cannot update the variable in the caller that holds the caller's array reference. Therefore, what Java is providing is not real pass by reference. In other languages like C++, you can choose to pass variables to methods by value or references. In Java, you cannot make this choice. Primitive type variables are always passed by value. When you pass an object, a copy of the reference to the object is always passed. A method can return a reference to an array. The return type of a method must be declared as an array of the correct data type. In this example, we have a public static integer square bracket getArray. So it tells us the return type will be an integer array. And inside, we have an integer array score, and we initialize some values, and we return the score. So just return the array name. So in the main, if you want to use this method, you can declare integer square bracket. So it's an integer array called scores from method. And this getArray method will return the array and assign to the scores from method. So what is sorting? Sorting is the process of putting a list or a group of items in a specific order. Some sorting criteria are alphabetic or numerical. Sorting can be done in ascending order or descending order. Sorting refers to ordering data in an increasing or decreasing fashion according to some linear relationship among the data items. Sorting can be done on names, numbers, and records. That is, sorting greatly improves the efficiency of searching. Swapping two variables refers to mutually exchanging the values of the variables. Generally, this is done with the data in memory. The simplest method to swap two variables is to use assert temporary variable. Here we want to swap val A and val B. So first we assign val A to assert variable temp. Then we assign the val B to val A, and we assign the temp value, which is originally val A, to val B. Bubble sort is one of the classic sorting algorithms for sorting taught in various computer and engineering courses. I think you already seen bubble sort in C++ class. In the bubble sort algorithm, we sort an unsorted array by starting from the first element and comparing with adjacent elements. If the former is greater than the later, then we swap, and by doing this, we get the largest number at the end after the first iteration. So in order to sort n elements, you require n-1 iterations and nearly n-1 comparison. The following procedure shows how the data is sorted in a bubble sort. The first one is you start comparing some number at index 0 to index 1. If some number index 0 is greater than some number index 1, then you swap the numbers. Then you compare some number index 1 to some number index 2 and repeat until you have compared the last pair. This is referred to as one pass, and at the end of the first path, the largest number is at the last. So repeat this comparison again, starting from some number index 0, but this time proceed until the second to the last pair only. There are other YouTube videos available in the modules to see the visualization of bubble sort. When you use a bubble sort to sort any array into ascending order, the largest value falls to the bottom of the array after you have compared each pair of values in the array one time. The second time you go through the array making comparisons, there's no need to check the last pair of values because the largest value is guaranteed to already be at the bottom of the array. You can make the sort process more efficient by using the new control variable to limit the repetition of the inner for loop and reducing the value by 1 on each circle through the array. So this figure shows how you can use a new variable named comparison to control how many comparisons are made in the inner loop during each pass through the list of values to be sorted. The comparison to make value is decremented by 1 on each path through the list. You can sort arrays of objects in much the same way that you sort arrays of a primitive type. The difference is when you sort an array of primitive element type, you compare the values of two array elements to determine whether they are out of order. When array elements are objects, you usually want to sort based on particular object field. In this bubble sort function, we are sorting array of the objects of employee class. So the bubble sort method header shows it receives an array of type employee. The temp variable we declare here is an employee temp. It will hold an employee object. The comparison for determining whether swap should happen use method calls to getSalary method to compare the returned salary for each employee object in the array with the salary of the adjacent employee object. So the result will be sorting the array based on employee's salary. Dot get salary, then round parenthesis is access method to get the salary of the object. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards in your hand. The array is virtually split into sorted and an unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. To sort an array of size n, in ascending order, we iterate from some numbers 1 to some numbers n. Compare the current element to its predecessor. If the current element, is smaller than its predecessor, we compare it to the elements before. Move the greater element's one position up to make space for the swapped element. You can take a look at the visualization of insertion sort in video section. For those sorting algorithm, you don't need to worry about memorize each line. You just need to understand how the algorithm works. Then later, if you want to use those algorithms, you can easily find online and find those functions. When you're using functions, pay attention what's their return type, what's the arguments they require. So you pass in the correct arguments, then you get a result, and according to the return type, you either assign the return result to a variable, or if it is a void function, you can print out the function, or you can use the sorted array later. Multidimensional arrays can be defined in simple words as an array of arrays. Data in multidimensional arrays are stored in tabular form. So the syntax is I will first have a data type. That's the type of data to be stored in the array. For example, integer, character, etc. Then we have a dimensions. First dimension, second dimension. We can into have an nth dimension. Then we have an array name. That's the name of the array. Then we specify, and we use the keyword equal new. That's the keyword. Then we have a data type. Then we specify the size 1, size 2, and to size n. That's the size of dimensions respectively. Here we have a two-dimensional array. We have 3 rows and 4 columns. Two-dimensional array is the simplest form of a multidimensional array. A two-dimensional array can be seen as an array of one-dimensional array for easier understanding. So the first index is a row index. The second index refers to column index. To access an element in a two-dimensional array, you need to supply first is the row index, then the column index. In this example, assume you own an apartment building with 4 floors. Starting from floor 0, then floor 1, floor 2, floor 3. So we have a two-dimensional array, integer, brackets, rents, equal to, and we can see that there are 4 rows. 4 rows stand for 4 floors. And for each row, we have 3 numbers. That means each floor, we have a 3 bedroom. So in order to access an individual element in the rents, we need to supply the floor number and the bedroom number. In other words, we need to supply the row index and the column index. When you pass a two-dimensional array to a method, you pass array name just as you do with a one-dimensional array. A method that receives a two-dimensional array use 2 brackets pair following the data type in the parameter list of the method header. For example, this method displays scores. It receives a two-dimensional integer array called scores array. In two-dimensional array, the length field holds the number of rows in the array. So if we say rents.length, that's 4, because the number of rows. And each row, in turn, has a length field that holds the number of columns in the row. So if we say rents index 1.length, so it will return 3 because we have 3 columns in the second row. In previous slide, the rents array is not a jagged array because it has the same number of columns in each row. Here, let's talk about the jagged array. A jagged array is an array of arrays, such that member arrays can be different sizes. So each row can have different number of columns. And here the syntax of defining jagged array. You define the number of rows of a two-dimensional array, but you don't define the number of columns in the rows. Then after that, you declare the individual rows using keyword new. The array class in java.util package is a part of a Java collection framework. This class provides static methods to dynamically create and access Java arrays. It consists of only static methods and the methods of object class. The method of this class can be used by class name itself. There are often times when loops are used to do some tasks on an array like fill an array with a particular value, sort an arrays, search an arrays, and many more. So array class provides several static methods that can be used to perform this task directly without use of loops. This table shows some of the useful methods of the array class. For each method listed in the left column of the table, type stands for a data type. An overloaded version of each method exists for each appropriate data type. For example, there's a version of the sort method to sort integer, double, character, bytes, float, long, short, and object arrays. Those are static methods, so when we call those methods, we just use a array class name with the array dot, then the method name. In this example, we have an arrays.fill method. It accepts two arguments. The first argument is the name of the array. The second argument is the value. So we will fill the array with 8. So each array element is 8. Then we change some elements values. Then we call arrays.sort, and then we pass array name. So .sort will sort the array element in ascending order. The array class binary search method provides convenient ways to search through sorted list of values of various data type. So here we have a position equal arrays dot binary search. There are two arguments. The first argument is the array name. The second one is the key to be searched. Keep in mind the array must be sorted prior to making this binary search call. If the array is not sorted, the results are undefined. If the array contains multiple elements with a specified value, there's no guarantee which one will be found. If the key is found in the array, its position is returned. If the key is not found in the array, a negative integer is returned. Array list is a part of a collection framework and is represented in java.util package. It provides us with dynamic arrays in Java. Though it may be slower than standard arrays, but can be helpful in programs where lots of manipulation in the array is needed. You can perform various operations on array list. For example, in order to add an element to an array list, we can use add method. This method is overloaded to perform multiple operations based on different parameters. They are add object, though this method is used to add an element at the end of the array list. We can also have add, then you provide the index and object. So this method is used to add an element at a specified index in the array list. In order to remove an element from an array list, we can use remove method. This method is overloaded for perform multiple operations based on different parameters. You can remove object. This method is used to simply remove an object from the array list. If there are multiple such objects, then the first occurrence of the object is removed. Also, we can provide the index to remove. So since an array list is indexed, this method takes an integer value, which simply removes the element present at that specific index in the array list. After removing the element, all the elements are moved to the left to fill the space and the indices of the objects are updated. If we wish to change the element, it can be done using the set method. The get method receives an integer and retrieves an element from a specified location in an array list. And the size method returns the current array list size. This figure contains a program that demonstrates each of these methods. An array list called names is created. and the type is string type. Then names.add, we add the string ABIGAL. Then we can display names. In the display function, we use the method .size. We also use the retriever method names.get. Then we have a names.add Brian, so we add Brian into the array list. Brian will be added at the end of the array list. Then names.add, then to, then Christy, so we will add Christy at index 2 of the array list. We also can remove name. Name.remove 1. Name in the index 1 will be removed. And we also call names.set 0 and net. So we will change the first name in the array that at the index 0 to a net. We can see those methods are not static methods. When we call this method, we use array list object names, then dot, then we call the method. Enumerations was added to Java language in JDK5. Enumeration means a list of named constant. In Java, enumeration defines a class type. An enumeration can have constructors, methods, and instance variables. It is created using enum, enum keyword. Each enumeration constant is public, static, and final by default. Even though enumeration defines a class type and have constructors, you don't instantiate an enum using new keyword. Enumeration variables are used and declared in much the same way as you do a primitive variable. So an enumeration can be defined simply by creating a list of enum variable. In this example, we have an enum, then we have a month, then we define Jan, Feb, March until December. An enumeration type such as a month is a class, and its enum constants act like objects instantiated from the class, including have access to the methods of the class. Let's see an example to define an enumeration and access its constant by using enum reference variable. So here we define a enum weekdays contain from Sunday to Saturday. Then for the weekdays, WK. So WK is an enumeration variable of type weekdays. Right? We declare it just like we declare a double type. Here we say weekdays WK. And the WK equal weekdays dot Sunday. So weekday can be assigned only the constants defined under the enumerate type. We can also assign other days like weekdays, Monday, something like that. Can only be assigned from the constant we declared in the weekdays. There are built-in methods, and each one is non-static. That means we must use with an enum object. Value and the value of both are static methods of an enum type and can be used to access enum elements. In this example, we have an enum restaurants and it contains the constant Domino's, KFC, Pizza Hut until Burger King. Then we have a restaurant and we declare R as a restaurant's type. Then we have a restaurants R array that's a bracket equal restaurants.values. So restaurant.values will return an array of enumerated constants. And we have a for each loop for restaurants A belong to the each element in our array. We will print out this A element. Then R equal restaurants dot value of Domino's. So value of accepts a string parameter and returns an enumeration constant. So actually it converts a string to the enum constant. So here we convert the string Domino's to R. R is in restaurants data type. Here we have a birth month. Month dot value of user entry. So user enter string, and we use a value of to get the constant of the month, right? Enum constant. Then we assign to the birth month. Then we say position equal birth month dot ordinal. So it will return the index that represents the constant position in the list of the constant. First position is 0. We have a comparison equal birth month dot compare to month dot June. So suppose birth month is March. The result, the compare to returns a negative integer if the calling object's ordinal value is less than that of the argument. 0 if they are the same, and a positive integer if the calling object's ordinal value is greater than that of the argument. So we say March is early in the year than June. If you have a September input, it will be later than the year than June. We can use the enumerations to control a switch structure. In this figure, we contain a class that declares property enumeration for real estate company, and then use a switch structure to display an appropriate message when the listing fee is 5% for single or multi-family property and 6% for condominium property. Because those are constant, so we can use in the switch expression. You can use the enum types anytime you need to represent a fixed set of constants. You can use enums when a variable, especially a method parameter, can only take one out of a small set of possible values. Enum is considered more type safe than constant. One of the common use of enum is to prevent the possibility of an invalid parameter. Using enum over constant help with the type safety, because if a function takes an enum and you pass it anything but an enum, the compiler will complain. With constants, you are accepting a pretty large range of data, most of which are invalid.